Okay, and then we just multiply the second part, which is cosecant x. And then the next term would basically be to add the derivative of cosecant x times just number 1. Yeah. Okay, so negative cosecant x cotangent x times x squared tangent x. So this is basically our answer. So we have that. I'm trying to see if we can simplify anything from here. So sine x over cosine x, and then sine x over 1. So this one definitely works. I'll try to, yeah. Okay, so 2x over 2x secant x, I think, right? Because sine x over cosine x times sine x over 1 is just 1 over cosine x. So that becomes secant x, right? And then plus x squared secant squared x cosecant x, and then minus just x squared tangent x cotangent x, and then cosecant x, but then we know that these two cancel out because they're reciprocals. So that means we just have a negative x squared times cosecant x, right? Okay, so that's basically our answer right here. Okay, and then number 14 is a quotient rule problem. And then this one, I think we can change it to product rule, but then for now I'm going to show or demonstrate how to do a quotient rule practice for trigonometric differentiation. So we'll just do quotient rule here. So y prime equals to 1 plus secant x tangent x times 1 plus tangent x, right? And then minus secant squared x times x plus secant x all over 1 plus tangent x squared. Okay, for this one, I would say it's a little bit more complex because you're multiplying like 2 terms by 2 terms. If you want to, I guess, distribute this, we can. But if you don't want to, it's fine. I'm just going to distribute it for the sake of distributing it. 1 plus secant x tangent x plus tangent x plus secant x tangent squared x, and then minus secant x secant squared x, and then minus secant third x all over 1 plus tangent x to the power of 2. Okay. Let's see if we can factor out anything here. I'm just gonna leave it like this. Yeah, it's a little bit too complicated. I think I'll just leave it like this. Let's just double check if there's any way that we can try to simplify this. Okay. I mean, simplifying this doesn't really make much of a difference. It's not like you can really, it's not like you can try to cancel it out with the denominator. So I think it's just the best that we leave it like this. Okay, and then number 15 on the next page. Y equals ln cosine squared x, so y prime equals 1 over cosine squared x, chain rule, so 2 cosine x times negative sine x, right? So make sure that you put a parentheses here to show that it's a product, not subtraction. So you have negative 2 sine x cosine x, and then you also have cosine squared x in the denominator, cancel it out a little bit, and then you get negative 2 sine x over cosine x, which basically gives you negative 2 tangent x. Okay, and then number 16, y equals tangent of secant x times sine x. So y prime would give us secant squared, secant x, sine x, and then do product rule for chain rule. So you get tangent x times sine x plus secant x times cosine x, right? Okay, and then you do secant squared secant x sine x, and then sine x over cosine x times sine x over cosine x. So this goes to that, this is this, and then this is this. So we see that we get sine squared x over cosine squared x, which is, interestingly, tangent squared x, right? So tangent squared x plus, and then secant x and cosine x multiplied to each other, they're reciprocals, so they're going to give 1 as your answer. And then, but then here, it's a little bit interesting because we know a trigonometric identity, right? 1 plus tangent squared x equals secant squared x, right? So since we have the trig identity right here, we can plug this in. So we got secant squared secant x sine x times just secant squared x. It's pretty cool. Yeah. And then going off to number 17, y equals cotangent of cosine x plus tangent x. So y prime equals negative cosecant, and the cosecant squared of cosine x plus tangent x, and then do chain rule. We don't need product rule right here because these two are not products, obviously. So we got chain rule product of negative sine x plus secant squared x, right? Okay, that's basically it for this one. No more simplification. Just gonna make the box a little bit pretty. Okay, and then off to number 19, y equals cosecant of e to the negative 2x. Y prime equals negative cosecant e to the negative 2x times cotangent e to the negative 2x, and then derivative of e to the negative 2x for chain rule would be negative 2 e to the negative 2x, right? So I guess we just got 2, and then cosecant e to the negative 2x, cotangent e to the negative 2x, all over e to the 2x. Yeah. I mean, some teachers don't approve of having negative exponents in your answers, so we can try to change that all to 2 times cosecant e to x over 1 times cotangent e to 2x, and all over e to the 2x. Yeah. Okay, and then we have until 22. Oh, actually we missed 2018. We'll go back later. Okay, y prime for 20 is sine, there should be a parentheses here, negative sine, and then 1 plus x squared, x to the 3rd power, and then chain rule of this, we need to do quotient rule for this one, so 2x times x to the 3rd minus what? Minus 3x squared times 1 plus x to the 2nd power all over x to the 6th power. Okay, and then we got negative sine 1 plus x squared, x to the 3rd, and then 2x to the 4th power minus 3x second minus 3x to the 4th power. Yep, all over x to the 6th power, negative sine 1 plus x squared, x to the 3rd, and then negative x to the 4th power minus 3x to the 2nd power times x to the 6th. Okay, so this looks a little bit weird, but basically what this is showing is x to the 6th power all over negative sine x, negative sine 1 plus x squared over x to the 3rd times negative x to the 4th power minus 3x to the 2nd power. So this would be our answer. Okay, let's just check our work really quickly to make sure everything's right. Yep. Okay. And then number 21. Y equals tangent of e to the secant x. Y prime equals secant squared of e to the secant x, right? And then we also do a chain rule. So derivative of secant x would be secant x, tangent x, and then e to the secant x again, right? Okay, and then that gives us, well, yeah, this is basically just the answer. Secant x, tangent x, e to the secant x times secant squared of e to the secant x. Yeah, this is our answer. Number 21, second to last one. Y prime equals secant, so since this is secant sine x plus 3 to the power of 2, like everything to the power of 2. So 2 comes out to the front and secant of sine x plus 3. And then chain rule, so secant sine x plus 3 times tangent sine x plus 3. And then we do chain rule one more time. So inside of this would be, derivative of the inside would be cosine x, basically, right? Okay, that's it. And then we got 2, and then, yeah, 2 secant squared sine x plus 3 times tangent sine x plus 3 times cosine x. Yep, so this would be our answer. And then before we end, we also have number 18 that we forgot about. So y equals sine cosecant x minus cosine x, this whole thing to the power of 3, so y prime, 3 comes out to the front, so sine cosecant x minus cosine x to the power of 2, and then chain rule, so cosine cosecant x minus cosine x. Okay, and then also one more time, chain rule of the really inside, the deepest one, which would basically be negative cosecant x, cotangent x, and then plus sine x, right? Yeah, that is right. And then we'll just do 3 sine squared of cosecant x minus cosine x, cosine of cosecant x minus cosine x. No, wait, yeah, sorry. There's one more parentheses, and then times, times negative cosecant x, cotangent x plus sine x. I think it would be the best if this part comes out to the front, so it comes out like to the front after the 3, the coefficient, so that it's not confusing. So it's not like confusing to see that there's one more parentheses that looks like a product of this part, which is inside cosine x. So to not confuse ourselves, I think it's the best to put this to the front. Yeah, right here. Yeah, right here. And then that would be our answer. If it's a little confusing, I'll get rid of this one for you. Okay, so this is going to be our answer for number 18.